So this is a calculation question that you could easily find on your test, and this is dealing with body surface area. So this is those special dosage calculations that we've been practicing. So a clue to your dosage calculations using your BSA, your body surface area, will always come in. Your body surface area will always come in when you see metered squared. Okay, so that M2 should be metered squared. In this program, it won't allow me to do that. Make that 2 look like the square that you're used to. So just follow along with that. So you won't be given your BSA formulas on the test, so make sure you get those memorized. So this is telling us that the order is 60 milligrams per meter squared PO, so that's orally daily. How many milligrams would you give a patient who is 5 feet 6 inches tall and 140 pounds? That's the first step to this question. The next step is the question asks further that the drug is supplied in a strength of 50 milligrams per tablet. How many will you give? So in this situation, we're given that the height of the patient is in feet, 5 feet 6 inches, and the weight is 140 pounds. So for our metric system, okay, you would be using centimeters for your height, combined with kilograms. Household, which is the American system, uses inches and pounds. So whether you decide to convert the pounds to kilograms, your in feet to centimeters, things like that, that's up to you. I recommend going with the simplest conversion possible. So for this example, you will be given on the test that 1 kilogram is equivalent to 2.2 pounds, and that 1 foot is equal to 12 inches. So those two specific conversions you will be given on the test. So the first thing that we're going to do is let's get these 5 feet 6 inches completely into inches. So what we need to take into consideration is that 5 feet. So 5 feet is equal to how many inches? Okay, we're not entirely sure. That's what we're trying to figure out. So using the conversion that we see up at the top right corner here, 1 foot is equal to 12 inches. That can be a unit fraction that we use in order to solve this. So essentially what we're going to do is we're going to have 5 feet, and we're going to multiply that by 12 inches per foot. That's our unit fraction. And again, making sure that your unit fractions line up. The point is to convert the feet to the inches. So the feet in this calculation should be canceling out, and they do. So 5 times 12 is actually 60, and don't forget your inches there. So 60 inches divided by essentially 1 foot, or just 1 at this point, is still going to give you 60. But remember, the patient is 5 feet 6 inches tall. So we have to add an additional 6 to completely get the individual's height. So 5 feet 6 inches actually converts to 66 inches. So now that we've converted into inches, we can now use our BSA formula. So BSA in our household system, our body surface area formula, is the square root of the weight, okay, so 140 pounds, multiplied by the height, which is 66, divided by that constant. And you won't be given the constant on the test. So the constant for the household is 3,131. For the metric system, it's 3,600. Okay? So if we do this calculation through, it's always a good idea to round at the very end of your math, because if you round too early, you're going to get your numbers off, and that will impact you on a test, especially when I ask you to round to the nearest tenth of a decimal place. So if we multiply 140 by 66, we get 9,240. We're going to divide that by 3,131, which is that constant. And we get a square root of 2.951133 823. So again, notice how I am keeping all of as many decimal places as possible. The square root of that is 1.7 metered squared. Do not forget to give me the metered squared, because if you just tell me 1.7, that number has no reference point. So I really want to make sure that you're understanding that concept. So make sure you write that metered squared. So the order read to give this patient 60 milligrams per metered squared orally daily. So now that we've determined that this patient's, based on their height and their weight, their body surface area is approximately 1.7 metered squared. So we're going to use that to determine how much of this prescription we should be giving. So we're going to multiply 1.7 meters squared by the order, which is 60 milligrams over 1 metered squared, because we need to convert the 1.7 meters squared. Well, what does that mean to us in terms of milligrams to our dosages? So yes, the metered squares cancel out, and 1.7 times 60 milligrams gives you 103 milligrams. So that's part of the question, understanding we're getting to that final part. So how many milligrams? We've answered that question. That's part A of that question. 103 milligrams would be administered to a patient weighing 140 pounds, a height of 5 feet 6 inches tall. But the drug is supplied to you at a strength of 50 milligrams, mg. Sorry, I'm just erasing that. 50 milligrams per tablet. Okay, so the second question is asking, well, how many tablets would 103 milligrams do? So this is another calculation where we're going to use the strength as our unit fraction with that determined 103 milligrams to figure out how many tablets that is. So we have 103 milligrams needed for our order. We're going to multiply that by 1 tablet over 50 milligrams. So now we're interested in getting rid of the milligrams and transferring that into tablets. So again, yes, the milligrams do cancel out. So 103 multiplied by 1 is going to give you 103 tablets, and we're going to divide that by 50. And when we divide that by 50, we get 2.1 tablets. And that's what you would be administering mathematically. Now, this isn't actually a question from the textbook, and it's one of the ones we've done for homework. So, mathematically speaking, 2.1 tablets is correct. In terms of the dose, chances are you would either go with 2 tablets or 3 tablets, because we very rarely break up tablets. But for the purpose of the test, if you were able to get to 2.1 tablets, that is what I want for you for the test. So I hope this helps in terms of a BSA calculation.